Hello all, today in this video I am going to provide details regarding a demo video for bagging regression already with the same code dataset we have done with some other different machine learning algorithms, and we have made a comparison that which algorithm is providing the better results when working with the algorithms we have made. So initially we are going to import the libraries and the dataset. So this is the dataset which we are using. So these are the features are the attributes in the data set. Here the yield variable is chosen as the y variable, and apart from that every variables or features are chosen as the x variable. And then we are moving with the pre-processing. For pre-processing we are working with the label encoder library, and after pre-processing we are making to display the data set with the confusion matrix, that is heat map. So this is the data set heat map. Now we are grouping our data set by using crop production and area. By this we are getting how many crop fields are there in the data set. This data set I downloaded from Kaggle. Some of our subscriber has asked from which link. I don't remember. Previously we downloaded from Kaggle. Please you type as a crop yield detection Kaggle means it may come. I'm not remembering it, but previously we downloaded the data set from the Kaggle only. So it is having more than 50 entries. So as I said previously, here we are splitting our data into x variable and y variable. Within the x variable we are calling all every features apart from yield, and in the y variable we are calling only the yield variable. And in the x variable we are getting the dummies, and then we are splitting our data set into x train, x test, y train and y test. And we are using the train test split function by using the testing size as 20%, that is 20% will be taken for testing and the remaining 80% will be taken for training. Previously with the same work we have done with linear regression and got an training accuracy of 83.94 and testing accuracy of 85.03. And also then we worked with, previously you can find the demo videos of this in the same channel. So now in this video we are going to work with bagging regression. So decision tree, previously we worked with an video and we got an training accuracy of 100% and testing accuracy of 93.82. Then with the random forest we worked, in that we got an training accuracy of 99.44 and testing accuracy of 95.29. Then we worked with gradient boost, in that we got an training accuracy of 99.79 and testing accuracy of 97.01. Then we worked with XGBoost, in that we got an training accuracy of 100 and testing accuracy of 96.089. Now we are going to see the demo for bagging regression. In the bagging regression you can see that we are initially importing the library which is needed for bagging regression, and then we are calling the bagging regressor within the BR variable, and then the number of estimators we are declaring as n is equal to 100, and then the random state as 1. Then we are training our model by using the x train and y train function, and testing our model by using the x test variable, and then we are declaring the variables like accuracy, mean square error and R2 score, and then we are going to display the accuracy of the bagging regression. Here I just forgot to give the bagging regression. Already we copied from the previous code, so it has some mistake. So here we have to give the bagging regression. Now it will we have to give run, so it automatically it will the output will be displayed as bagging regression output, that is training accuracy and testing accuracy. It may run. So in the down we have made an comparison of what are the algorithms we have done. So here previously we have worked with the linear regression, decision tree, random forest. So we every algorithms we have worked with we have made to display in the models, and then this models we are calling here here within a for loop, and within the for loop we are declaring the fit function, that is training function, testing function, and also the values for accuracy, mean square error and R2 square error. So now we are going to declare the accuracy of every model. Previously we didn't notice the accuracy of bagging regression. Now it is running. So the bagging regression accuracy is 99.49, that is training accuracy. Testing accuracy is 95.54. Every accuracies you can see it is displayed over here. I think the code, so more or less this is the same, 99.49 and 95.54. So previously we the only change we did is the bagging regression. No, other than that everything is same. XG boost is only the correction we have done, right? Then we are going to make to display a comparison table. So in the comparison table we are set like the least model will be shown with uh, red color, and the highest model will be shown with green color. So this is the difference you can see. So linear regression is the least model as of now. Then so it is showing red color, and the gradient boost is the best model as of now. So it is going showing green color. So after gradient boost, the XG boost takes the place, and after XG boost, bagging regression takes the place. After that, random forest followed by decision tree, and finally this is the linear regression. So in this work we have worked with the bagging regression and also made a comparison of every other models with this particular data set. Why we are going with regression? Because where our data set is having both numerical and categorical data set. So when coming to this regression model, it will work better other than this classification model, because mostly classification model, if you see, means it will work only with numerical data or categorical data. So since we are data set is having both numerical and categorical data, we have moved with the regression model other than classifier model. So in the next video, we will be working with the k-nearest regression model. So if you are interested in knowing some other demo video means, please let us know in the comment box. Thank you.